Okay, let's convert 7/8 into a decimal. So we set up our division house. The first number makes it inside the house. The last number gets stuck outside. 8 doesn't go into 7, so we add a decimal and a 0. 8 times 8 is 64. I subtract 70, take away 64 is 6. Put up a 0 and bring it on down. 8 goes into 60 7 times. 7 times 8 is 56. I subtract and I get 4. Put up another 0, bring it on down. And luckily for us, this works out evenly right here. 5 times 8 is 40. And so we don't have to keep going. That is our answer, 875 thousandths. The code word for this video is tissue. Okay, this one we're changing into a fraction. And so since it's repeating, we need to kind of use our kind of funky, weird method. All right, so right now it's 0.13 and the bar is just over the 3. So I'm going to write a few 3's just to get the sense of what's happening. I ask myself how many digits are repeating. And in this particular decimal, just 1 is repeating. So that means I'm just going to multiply it by 10 because that is 10 to the first power. When I do that, I multiply by 10, it moves the decimal over just once. So now I have 1.33333. So I'm going to line up my decimals and write down a couple 3's so I get the hang of that. Okay, at this point I'm subtracting one equation from the other. 10x, take away an x, is 9x. Now you have to be really careful here, guys, because these 3's are all going to cancel out until you get to this point here. And you have to kind of stop because this is 1.3 and we're subtracting 0.1. So 3 minus 1 is 2. So 1, so we wind up with this equation, 9x equals 1.2. In order to get x by itself, we divide by 9 on both sides. And we're left with 1.2 over 9. We can't have a decimal inside a fraction. So what can we do? We can bump this decimal over once. And whatever we do on the top, we have to also do on the bottom. And we'll put a 0 to keep that space. So we wind up with 12/90ths, and that fraction can be simplified. And so when we do that, we are going to divide both of these by, let's see, we can divide by 3, I know. When we do that, we get 4 over 30, and that actually can be divided again by 2. And so we wind up with 2/15. And what's really cool is, I know you don't have the calculator when you take these concept checks, but you can always check it later, you know, especially when you're doing your corrections. If you turn on your calculator and say 2 divided by 15, you get exactly what we wanted. So that's always a good, validation there.